All right, we're going to do another congruence postulate. It's really only one congruence postulate, but I will show you what it looks like. So let's draw a couple triangles. Again, it doesn't matter what the triangles look like at all. So here's my triangle. I'm going to copy and paste that one, put it right here, and we'll just go back to our old everyday A, B, C, D, E, F. Everybody loves that one, right? Okay, so here's what's new. We've done angle, side, angle already. We've done side, angle, side already. So this one's a little bit different. This is actually a theorem. Don't know, what do you need? All right, too late. You took too long. All right, so what we have here is this. This is a theorem, okay? It says applying the postulates. I'm not going to get into great detail on this, but I'll just show it to you. So what if you had two angles and then another two angles that are equal to each other? Now watch. Yesterday we said if we knew that this side was equal to this side, then it would be angle, side, angle. Then they'd be congruent. There's another one. Everybody listen. There's another one that we're going to learn. This is a theorem this time. This could be proven. All right, so this could be proven. We're not going to in here, but it could be. So watch. If I have two angles equaling two angles, and I have a side that's not in between, it could be here or it could be here. It doesn't make any difference. That's enough to know. Listen. That's enough to know that these triangles are congruent to each other. So I don't call this angle, side, angle because that side's not in between those two angles. What do you think I'm going to call this then? Well, I'm going to start with the angle. It's not side, angle, side. There's not another side here. There's two angles in one side. You can't say side, angle, side if there's two angles in one side. It's angle. It's not angle, side, angle. Listen to me. It can't be angle, side, angle because that means it would be this side right here equaling this side right here. This is called a non-included angle. A non-included side. This side is not in between those two angles. Shh. Zion. What's up with you today? You're usually really good and pay attention and listening. Okay, well, don't talk to him. It's as easy as that. Problem solved. So we're going to call this angle, side. So this is called the angle, side theorem. It's not a postulate, it is a theorem. I'll show you real quick. No, I'm not even going to do that because time's running out. All right, so if you have that information, that would be telling us that we have congruent triangles. Okay, so if you have two angles and a non-included side, what does that mean, a non-included side? That means the side is not in between the two angles. That side right there is not in between these two angles, is it? All right, so we call this angle, what? Side. All right, I guess some people could call it side, angle, but nobody ever does. Okay, we call this angle, side. And it could have been, whoops, let's get rid of these. It doesn't have to be this particular side right here. I could have done this. I could have said this side and this side. All right, if I told you that those two sides were equal, these two angles were equal, then again, these are congruent to each other. These triangles are congruent because of angle, side. All right, so that's the reason why they're congruent to each other. All right, let me teach you one more thing here. Let's draw a couple triangles again. Actually, let's just draw one big triangle for right now. And I'm going to try to make this as accurate as I can. It's a little off. I can fix it by doing this. I want this one to line up with that. Okay, that's not too bad. All right, so what I have right here is this. This side and this side, it's given that it's equal to each other. We have a theorem, and by the way, what kind of triangle is this? If two sides are equal to each other, we have a name for it. We just did this not too long ago, last week, I think. It's isosceles, right? This is an isosceles triangle. And in fact, they call this an isosceles triangle theorem. Okay? So this is an isosceles triangle theorem. Here's what it says. Everybody watch. This is super important because you're going to do some problems where you're going to have to know this. So if these two sides are equal to each other, what this theorem says is that the opposite angles must be equal to each other as well. All right? So we'll call this ABC. What's the opposite angle of this side right here? Angle what? Angle C, right? So if I go across from it, so that means that this angle is equal to what? The angle that's across from this side, B. So if you knew that AB was equal to AC, then what do we know about it according to this theorem? We know that angle B must be equal to what? Angle C. Angle C. It can't be A. You're just yelling things out. You're not even thinking. All right? The B and the C are the ones that are equal to each other. All right? Just think before you answer. I don't mind you just yelling out answers. I don't mind that. Even if it's a wrong answer, I get it. You know, I'm not asking everybody to be perfect, but just think a little bit. All right? So if this side was equal to this side, then this angle B equals this angle C. Why? I've talked to you already about it. Now, the converse of this is true as well. So watch this. I'm not going to redraw the triangle. You can draw a second triangle if you want. Oops. Let's just get rid of this. Come on. Let's get rid of this little tick mark right here. Now, here's the second part of this, and we'll basically be done. What if I told you that angle B was equal to angle C? Okay, so if I told you if angle B was equal to angle C, that's different than this, isn't it? Because what did I tell you over here? That the two sides were equal, right? I didn't tell you the sides were equal here. I told you the two angles are equal. So what does that tell us, though? What do you think it tells us about the opposite sides? So if these two angles are equal, guess what? Then these two opposite sides are going to be equal to each other. It seems like it's the same exact thing, but it's different because I tell you different information. The first one I said, if the two sides were equal, then the two angles were equal. This one is the converse of the isosceles theorem, triangle theorem. It says, if the two angles are given to be equal to each other, what can I say about these two sides? Then they are, don't say the same, they're congruent or equal to each other, okay? Then, what? AB is equal to AC, all right? They look the same, but they are a little different, okay? So, for instance, what if I said this was 30 degrees and this was 30 degrees, and I told you the length of this was 5, and I asked you to find AC? Should be pretty easy. What if I told you this was 30 and this was 30, and I told you the length of this was 5? I want you to find the length of AC. What would that be? It'd be what? 35? Why 5? Because these two sides would be what? Equal to each other, right? I never said anything about adding up an angle and a line segment. Okay, these two sides would be equal. So if this was 5, then this would be what? 5, okay? What if this was like x plus 3, okay? And then this would be x plus 3. And what if this was 5? What would you do? You'd set them equal to each other, wouldn't you? You go x plus 3 equals 5, so x is 2. X is 2. 2 plus 3 is 5, okay? All right, your homework is 4. You can look at the page numbers. It's 1 through 12 and 18 and 19. So that's your homework right there. Get that done for tomorrow.